Hi everybody. Welcome again to week 5 of Graduate Statistics, University of Cincinnati. This is our second video lecture for this week. And we ended the previous one with a question, right? We determined, based on the promotion data, that there was a difference of 30% in promotion decisions that are gender-based. So 88% of the managers that received a male-marked file did the go-ahead for promotion, and only 58% of the managers made that same decision when receiving the same file, except marked as female. Now, we wanted to know whether a difference of 30% in promotion decisions is likely or not, assuming that there is no gender discrimination, right? Assuming the null hypothesis, such that we could trust that that difference is meaningful and that we should be concerned with gender bias. So what we'll do to answer this question is to work together through the guided activity of Lab 5. So if you can open up your RStudio Cloud project and work along and with me, that would be nice, because what I will do, I will stop and ask you to think about things, try things out before we continue. Deal? All right, so we're doing a lab on Introduction to Statistical Inference, and as I said, the aim of this lab is to provide you with an intuitive introduction to the process that support data-based inferences, that is, inferences about what goes on in the real world based on what is observed in our data. All right, as usual, we'll start installing the 2 packages that so far have been sufficient for us to do our data analysis, which is ggplot and the tidyverse. All right, so this is done. So, Introduction to Statistical Inference via Simulation. This is our case study. Gender discrimination in promotion decisions. As I said, to recap, in 1974, as part of a study on gender discrimination, 48 male bank supervisors were each given the same person's file and asked to judge whether the person should be promoted to a branch manager job that was described as routine. So here is the reference in case you want to look at it. And the design was as follows. For half of the supervisors, the file indicated that the workers' assigned sex was male, and for half, the assigned sex was listed as female. Let me actually save this as something else. Okay. The experimenter then randomly determined which supervisors got a file marked as male, so there's random assignment, and which got the file marked as female, right? Applicants' assigned sex was an independent or explanatory variable because there was that manipulation, right? So somebody just marked the file as female and male and gave it to the bankers. The outcome measure, also known as dependent variable in this case, were the supervisor's promotion decision, which is a categorical variable with 2 levels that classifies the applicant as either promoted or not promoted. Question of the study, are females unfairly discriminated against in promotion decisions? Maybe let's complete that. Now let's load, let me get this out of there. Let's load the data gender discrimination with the read.csv function that's familiar to you by now. And the name of the data set is data, which is right there. And we're storing it in an object called data gender discrimination. And if we load it, it appears right there. If you want to see it here on the RMD document, you can just write down the name of the data set so we can look at it. But remember, if the data set is very, very long, it will end up generating a lot of output in your when you knit the file. So to avoid that, just make sure you comment it out before knitting. So now let's look at it from clicking on that object that we stored the data set on the workspace of our global environment. So we have the supervisor here, 1 all the way up to 48. Some of them were given the mail file, half of them, and half of them were given the mail file. And we have their decisions on this column called promotion decision, right? So they decided whether they promoted or not promoted. So this is the data set. And as usual, if you ask the question about promotion decisions and how that was distributed based on gender and, assigned sex at birth, it's hard by just looking at this data set to make sense of it. It's not information yet. So what is the first step in transforming data into information? We organize and we summarize the data, right? So let's start by organizing the data. Because we have here a response variable that's categorical, all we can do is count the number of promotions and the number of decisions to not promote the applicant. So let's organize that into tables. These counts into tables, much like the ones you've seen in the slides. So again, our goal is to organize the data in a way that lets us see the relevant pattern in it. That is, the pattern that helps us see a possible answer to the question we posed about gender discrimination in promotion decisions. So let's learn how to create a table for a single variable. So we will try to create a table that displays how many supervisors promoted the applicant and how many did not. We'll use the function table, which takes as input the variable that we want to summarize. And here I would like you to stop the video and give it a try. Let me just give you some hints. You know that when you're using a function, you type the name of the function and the input that that function needs inside the parentheses, the input or the inputs that the function needs inside the parentheses. I'm telling you that the input that this function needs is the variable that we want to summarize. And we want to summarize the promotion decisions. How many were promoted, how many were not promoted. Okay, so it needs this variable as input. The function needs this variable as input. So pause the video and give it a try. And then come back when you're ready to see the answer. All right, so to use the function table, I type the name of the function. I open parentheses, and I need to tell R that I want it to summarize this variable promotion decision. Except promotion decision is not in the workspace, so R can't see it. It can, however, see the data set that houses that variable, right? So what we need to do is to do some subsetting here. We say data, gender discrimination, $, promotion decision. So that's the one I want to summarize. So if I click here, I have the summary. 13 not promoted and 35 promoted. Now another challenge to try and help you recover things from previous classes. Could you please store or assign the table you just created to an object called data counts so that it shows up here on the workspace? Pause the video and give it a try. Come back when you're ready for the answer. All right, I'm gonna assign, so this is the table we just created, so I'm gonna copy and paste it here. And I said assign it to an object, store it there, called table counts. Remember, that's the assignment operator. So if I do that and I run, I then have stored our table in an object called table counts. So if I want to see this table later again in my output, all I need to do is type the name of the object and it brings the table back. If I don't do that, it's not saved anywhere, so I have to type the full command again. On to question 1. We have organized the data into a simple summary table that shows the counts of supervisors who promoted and didn't promote the applicant. Yes, sorry. That shows the counts of supervisors who promoted the applicant and the count of those who did not. But does this table let us see the pattern in the data required to answer the question of the study about gender bias? If not, why not? Pause the video and type your answer right here. I keep pausing mine instead of yours. Okay, so the answer should be no, because we have the overall promotion and not promotion counts, but we don't have a breakdown by gender, right? By the gender that the supervisor saw in the file. So that's not helpful. Question number 2, then what is the solution for summarizing this data? How would you tabulate this data? See, this is me checking your understanding of the video lecture number 1. What is the type of table that I need, right? I have to tabulate. Sorry, I'll give you some time. Pause the video, come back when you need the answer. All right, the answer is sort of hinted to you right there. So we need contingency table, a table that displays promotion decisions broken down by the gender that the supervisor saw in the file. Does that make sense? So let's create that contingency table. Again, I am using the function table, but instead of just giving it one particular variable, which is what we've done before, I also ask it to break down by the applicant, which is the variable that provides the classification of the applicant as female or male. So if I do that, then I have, bang, my contingency table that you saw in the slide. So not promoted and promoted, the rate of female promotion, the rate of male promotion. Sorry, the number of females that were not promoted, the number of males that were not promoted, and here on this column, the promotion, the positive promotion decisions. Now, question number 3. Could you please store or assign the table we just created to an object called contingency table? This is the same thing we have just done for storing the table counts. So as a general tip, when I ask you to do something in a document, try to look back within the same document and find some code, some piece of code that does a similar thing. All right, so try and do that. Give it a, pause the video, try that, and come back for the answer. So the one thing that we did, the assignment that we did was right here. See, could you please store or assign? So let's get that. So you know how to assign, but actually we want to, you could do that, copy and paste, as I said. Let me keep my thing that I just suggested to you. So you can copy it here and then say, but I don't want to call it table counts. I want to call it contingency table instead. So I do that here. And on the contingency table, I don't want to store the simple table. I want to store the contingency table. So I copy and paste it here. And this is just to organize the thing a bit. You don't have to do that. And now you can display the table by calling it on the gray box. So there you have it. So contingency table is now stored here, which this piece of the code ordered R to do, and this piece of the code asked R to print it. So that's the end of our first video. Come back for more. Bye-bye.